Now we'll discuss how to configure addresses, which is where the communication takes place. There are parts of an address that are interesting. The scheme corresponds closely with the binding. For example, HTTP goes along with HTTP bindings. Net.tcp is for the TCP binding, net.msmq is for MSMQ binding, and SB is for Azure Service Bus, and so on. The machine is the physical machine or the domain where the web service can be found. Ports can be added. They're optional though. And then there's a multi-segment path that you can add, which is a virtual description of how to find the web service. Let's go see how to work with addresses. Here we have a solution with the web service project, and the app.config file is opened right now. The first thing I want to show you is this host element. Notice that it has a base address, and the base address has a scheme, a machine, an optional port, and a path. Now this is the base address for any other addresses that don't specify a fully qualified address. In particular, notice this endpoint, the address is empty. That means that endpoint uses the base address as its address. Now down here on the metadata exchange endpoint, we have an address set to MEX. Well, that's a relative address. So the fully qualified address of the metadata exchange endpoint is going to be http://localhost 8733/weatherservice/MEX. Alternatively, you can specify the whole address right there. Now when we run this, we'll still get the test tool coming up with our service, and it'll work just fine. And that is addresses. Now we'll discuss configuring bindings. Bindings define how you communicate with the service, and there are several options to choose from. You can choose encodings. Examples are text, XML, or binary. You can choose protocol. Examples of protocols are security, reliability, or transactions. You can even configure transport. Examples of transport are TCP, HTTP, or named pipes. Here's a list of some common bindings that ship with .NET. The basic HTTP binding supports the WS Basic Profile, which gives you the widest degree of interoperability with other platforms, and also supports the old ASMX web services style. A newer binding is Net HTTP binding, which is just like BASIC except that it has a binary encoding instead of XML. The Net MSMQ binding supports message queues and supports cross-machine interoperability. You can use Net TCP binding as a very secure and efficient cross-machine protocol that has binary encoding over TCP/IP. Net named pipe is built for communication on a single machine. Imagine you need to have two applications that communicate with each other, and this is ideal. The Web HTTP binding supports REST protocols. And then there's WS HTTP binding, and that supports a lot of the WS star type protocols that promote interoperability across systems and support standards like WS Trust, WS Security, WS Transactions, and more. So let's go see how some bindings are put together and configured in your application. Here we have a WCF web service project with the config file open so that we can work with binding. This basic HTTP binding is what gives you access to the WSI basic profile, and it's also the binding that Visual Studio creates for you when you create a brand new WCF project template. I'm going to change it to net HTTP binding, which is the new binding that's just like basic HTTP binding, except that it supports binary encoded files. If I press F5, then it brings up the WCF test client so that we can make sure that our change was good. I'll select that temperature, invoke, yes, that's good. Now you can have multiple endpoints for a single contract. Let's add a couple more. By selecting that binding, deleting it, and hitting Control Space, I can get a list of binding types. And I'll select the net name pipe binding. And make sure that the scheme matches the binding. And here I'll add one more. And I'll make sure that this address is unique also. So there I have a couple more bindings for that one service right there. Let me run it. And this brings up the WCF test client, and we can test each one of these services. So that was the TCP. This one's the name pipe. Okay, so they all work. And there you have it, adding bindings to endpoints. .NET already ships with several bindings that support common communication scenarios. However, when one of those scenarios don't meet your needs, you can still customize those bindings. You can support a single contract with multiple endpoints. Whenever you have multiple endpoints supporting a single contract, their addresses must be unique. To customize bindings, you would add a binding section to the system.serviceModel element. Then you can associate a binding customization with an endpoint by adding a binding configuration to that endpoint that identifies the name of the binding. Let's go customize a binding now. Here we have a web service with some pre-configured endpoints. Each one of these endpoints has an address, a binding, and a contract. Now these bindings are used in the pre-configured .NET bindings, for example the net name pipe and net TCP. Now if you wanted to configure these bindings, it's easy to do. Underneath the system service model, you can add another element called bindings at the same level of services. Underneath the bindings you can see a couple different bindings that we have configured here, the net name pipe and the net TCP binding. Now what you might also notice is that the name of these elements correspond to the built-in .NET elements. For example, this net named pipe binding corresponds to this binding right here, and the net TCP corresponds to the net TCP binding here. What that means is that whatever configuration we have in this custom binding will automatically apply to the endpoint where that binding is used. So, for example, we have binding in security mode equals none on both of these. That means on these two binding types that match these two endpoints up here, their security mode will be set to none. And by the way, you wouldn't set security mode to none in production, but I'm just trying to simplify the demo here. Now, if you wanted to apply a binding specifically to a endpoint, you could go to this binding element right here, and there's a name attribute. So I can give this a name, and I can call it the net named pipe binding config. So this is just a name that I can use for anything. It's just an identifier. So I'm going to copy this, and if I wanted to go and apply this specifically to an endpoint where I wanted that customization to be applied, I could go up and I can find a matching endpoint where the binding was compatible, and I could say binding configuration equals, and then there it is in the list right there. I select it. So this has now got a custom binding configuration that corresponds to this binding configuration down there. And so that's how you customize binding configurations. Configuring a client is much like configuring a service. What you would do is go to the system.serviceModel element in your config file and then add a client element. You can add multiple endpoints to your client configuration and name each one of them. Then in your code you can go to the proxy, and in the proxy constructor add any name to whichever endpoint you want to use. So let me show you how to do that. Here we have a web service project, and it's already configured with several endpoints, as you can see right here. What we want to do is add a client and then configure the client. So I'm going to right click on this, say add new project. We'll create a console application and call this a weather client. Press OK. And we have client code here. Now this weather client, it needs a reference to that service, which is a service reference. So we'll add that, click discover, service is there, and we'll give it a namespace. Weather service proxy. And that generates the proxy right there for us. Notice that we also have a system.serviceModel added to the list of references. Now, when we generated that proxy, we also generated a config file. Under system.serviceModel, we have a binding section and a client section. Instead of a services section, we have a client section. And what the service proxy generator did was read the metadata from the service to determine what these endpoints and bindings should be. So this is really already configured for us. Now if you needed to, for example, if the service provided another binding, you could go manually add that binding here via another endpoint and just go ahead and type it in there and update and everything. But of course you always have this update service reference, so whenever you change and add a binding to the service, you can do update service reference, and it's going to pull that configuration in here. And so that's very easy to work with. So let's go write some code to use this. This weather service client is the default that's created by the proxy service generator, and we're going to add a using statement for it. And then we're going to use that proxy to get the temperature. And print the result. And then we're going to stop the console. so that we can read the result. Now, this code has an error. I'm going to run it anyway, but before I do that, I'm going to set this as the startup project. And then press F5 to run that. And here's our exception, invalid operation. Essentially what it's saying is that an endpoint can't be found for this service because there's more than one endpoint. And we know that. Sure enough, there's 3 endpoints sitting there, and each of these endpoints has a name. Right there and right there. So I'm just going to grab the name of one of these endpoints and go back here, and in the constructor of the proxy there's a constructor overload that takes an endpoint name. So now there's no ambiguity, and when I run this, you'll see the output you expect. So that's a little bit about how to configure a client via declarative configuration.